Okay, so today we're going to be adding to ways that we can solve a quadratic with what's called the quadratic formula. So the quadratic formula we also use when we have a quadratic that's in standard form. So quadratic in standard form, ax squared plus bx plus c equals 0. So similar to when we're factoring, getting it set equal to 0, we have a quadratic in a linear term, or we have a variable term in more than one place. But we can really use the quadratic formula for any quadratic. We can use it for a factorable quadratic that's not factorable. We can use it for a quadratic that does only have one variable term, that doesn't have a linear term in the middle. Really, any quadratic can be solved this way. It's not always the most efficient way to solve, but sometimes it's where we have to go, depending on what the numbers are that we have to work with. So our quadratic formula, I'm going to write it out first, and we'll talk about ways we can remember this, because we're going to have our formula memorized. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's our quadratic formula. It's important that it's all over 2a, so including this term out front and our radical here. Now, a, b, and c, those values are coming from the coefficient in front of our x squared term is a. The coefficient that comes from in front of our linear term is b, and then our constant term is c. So we're just substituting in our values a, b, and c into our quadratic formula, not including the variable term. Now, the way that if we were in person, we'd all sing the quadratic formula together. You can remember the quadratic formula fairly easily, singing it in your head or out loud to the tune of Pop Goes the Weasel. And it works. I mean, I'm telling you, I see my students 4 years later and they still know the quadratic formula by memorizing it this way. Or you can find a different, there's other songs out there, there's people who just memorize it. But I'm going to sing it to you a couple times, and I'll also post a video with just the song in it with these notes, okay? But it's a good kind of practice to be able to write this without having to look at it. So after you do it a few times, see if you can write it down from memory, okay? So the song, again, it's to Pop Goes the Weasel, would go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Clearly not a singer, I'm a math teacher, okay, but it works and it helps you remember the setup so that you don't have to keep flipping back and look at the quadratic formula. Okay, and I'll post that song in there as well. And I encourage you to kind of start humming that tune as you're writing it, and I'll help you just remember. So now let's talk about the ways that we have to solve quadratics after singing to you. Let's move on. So now we have square roots or inverse operations. Oops, what am I doing? I don't know what I'm doing there. Inverse ops. Okay, that's one option. And for that, we need to have a single variable term, or we have that parentheses squared going on, right? Then we have factoring. Has to be factorable. A lot of quadratics are not factorable, so factoring is nice and it's really fast and easy if we've gotten pretty good at factoring by now, hopefully. But we're going to see that not every quadratic is factorable, especially tomorrow. We'll see that in our notes or next week. And so we can't always rely on this when we have a quadratic in standard form. And so now we have this other method, the quadratic formula. So when I'm going to solve a quadratic, I'm deciding between these three. And so factoring in the quadratic formula, many times we're using when we have a standard form of a quadratic, that ax squared plus bx plus c going on. I can either factor or use the quadratic formula depending what I have here. For today, we're going to look at quadratics that are factorable, and we're going to look at how is it different if I solve using the quadratic formula. I honestly would not suggest that if it's factorable, I would factor it. It's faster. So I wouldn't suggest just relying on the quadratic formula for everything. But one thing that is nice for the quadratic formula, like I said above, is it will solve any quadratic, okay? So this one's limited. It's not going to solve every quadratic for us because not every quadratic has a single term. Factoring is definitely limited. There's not, every quadratic's not factorable, okay? So they work sometimes. The last method works all the time. So it's just kind of a nice thing to have in your back pocket that if these two methods aren't working, even if it is factorable, I can switch and go here and I know that it'll work and that I can solve it using the quadratic formula. Okay, so first quadratic we're going to look at, if I wanted to factor to solve this, first we need to get it set equal to 0. Right, so set equal to 0, just like always, 2x squared, and writing it in standard form, minus 7x, subtract 9 equals 0. And then I will factor and solve. Factoring to solve when it is factorable is certainly faster. So 2x and x, I see that I have a negative c value, so I know I need opposite signs. And I want it to oi to negative 7, so I want 9 and 1, negative 9, positive 1. That's going to give me negative 7 for my middle term. And now I can get my solution. So x equals 9 halves and x equals negative 1. Okay, easy peasy, we've been doing that for a while, factoring to solve. Now I can take this same quadratic, and we're just going to start with ones that are factorable, because it's just going to give us a little bit of easier kind of simplifying at the end. So again, first, to use the quadratic formula, just like factoring, the first thing we need to do is get it set equal to 0. We can't use the quadratic formula when it's not set equal to 0. So first I have to get it in that standard form. So it's set equal to 0, just like before. And then let's identify A, B, and C. So A equals, B equals, C equals. So remember, these are just the coefficients. So let me go back up. AX squared plus BX plus C. So A is just 2, the coefficient in front of that quadratic term. B is negative 7, the coefficient in front of my linear term. And C is negative 9. Okay. And now it's just really going back to like unit 1. It's a game of substitution and simplify the expression. So we're going to substitute and simplify. Okay, you ready? Our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's our quadratic formula. We are going to substitute in the a, b, and c values I have here into this formula. So when b is negative, negative 7 is just going to be positive 7. Okay, because it's negative b, opposite of negative 7 is just positive 7. Plus or minus the square root of, now I could plug in and write this as negative 7 squared, but I'm going to go ahead and go negative 7 squared. And remember, whether I'm squaring a negative or a positive, it's going to end up being a positive number. So when I do, let me just kind of write over to the side, negative 7 squared, okay, is going to give me positive 49. So b squared is going to be positive 49 minus 4ac. And we'll talk about being really careful about our signs there. All over 2a. 2 times 2, 2a. I'll write it out right now. Now I'm just going to clean up. I'm going to keep going. So I'm going to have 49. Negative times a negative here is going to make this a positive overall. So I have negative 4 times 2 is negative 8 times negative 9 is going to give me positive 72. You have to be really careful whether you're going to add this second term or whether you're going to subtract. You have to think about how many negatives you have in that negative 4ac. Okay. All over 4. X equals 7 plus or minus the square root of adding 49 and 72 together gives me 121 all over 4. Now, this 121 is a perfect square. So that means I have 7 plus or minus 11 all over 4. And now I can get my two answers because I can do 7 plus 11. Let me split this. 7 plus 11, giving me 18 over 4, which simplifies to 9 halves. And 7 subtract 11, giving me negative 4 over 4, simplifying to negative 1. Okay, 7 plus 11, 7 minus 11. There are my two answers. Same answers, right? Should be the same answers. It's the same quadratic. This took us a lot longer, but it was also the first time we went through the formula. Once you get used to using the formula, it's pretty quick. Okay, but we're comfortable here. So if you can factor, I'd still encourage you to do so, but for the next couple of days, we're going to practice doing both. Okay, so let's look at another example here. So first thing I want you to do is pause the video and write your quadratic formula down. Okay, don't look back, just write it down first and pause the video and then restart the video and see if you got it correct. Okay, so quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Check your formula really carefully because you don't want to mess these up because your formula is wrong. Okay, now I want you to again pause the video and try plugging in a, b, and c values, substitute and simplify for the next two quadratics. I want to remind you that first you have to set it equal to 0 and then substitute and simplify. Okay, make sure you set it equal to 0 first before you try using the quadratic formula. Okay, so hopefully you tried these on your own first. I didn't want to just write it all out. I want to kind of just talk through what I'm doing. So first I get it set equal to 0. And on my first quadratic, a is 3, b is 1, right? That's 1x. And c is negative 10. Notice you never take the variable with you. It's coefficients and then your constant term. So x equals negative b would be negative 1 plus or minus the square root of b squared. 1 squared is 1 minus 4ac all over 2a. 2a would be 6. X equals negative 1 plus or minus the square root of 1. Negative times a negative is going to make that positive, and it gives me positive 120 when I multiply these three numbers together. All over 6. So I'm negative 1 plus or minus the square root of 121 over 6. And again, I have a perfect square here. So the square root of 121 is 11. So I know my solutions. I'll do negative 1 plus 11 over 6 and negative 1 subtract 11 over 6. So one solution, negative 1 plus 11, giving me 10/6, which reduces to 5/3. There's one solution. My other solution, negative 1 subtract 11, giving me negative 12/6, reduces to negative 2. Okay, so two solutions using the quadratic formula to solve. Same on this other one, getting this set equal to 0, make sure you write it in standard form. So when I subtract 13x over, it's got to go in the middle. So I have the right a, b, and c value. A is 2, b is negative 13, and c is positive 21. Okay, plugging that into my quadratic formula, x equals negative b, so negative 13 is going to be positive 13, plus or minus b squared gives me a positive 169 minus 4ac all over 2a, and 2a here would be 4. X equals 13 plus or minus the square root of, now notice here, I only have one negative, so I'm going to end up subtracting the result of this multiplication. So I have 4 times 2 times 21. I'm going to be, I'll have 169 subtract, multiplying these together, 168 all over 4. Okay, So here it became positive because I had two negatives. Here it's going to be a subtraction, which means I have 13 plus or minus the square root of 1 over 4. And the square root of 1 is just 1. So I have 13 plus or minus 1 over 4. 13 plus 1 would give me 14 over 4, which I can divide by 2, giving me 7/2 for one solution. 13 subtract 1 gives me 12 over 4, which reduces to 3. And there are my two answers. Okay? So now what I'd like for you to do is solve the equations we just solved. Okay, they're the same quadratics, but I want you to go through and solve them by factoring. So again, pause the video and solve these by factoring. Okay, so here I have my two solutions by factoring. So again, we still need to set it equal to 0, find our factors, and solve for each factor. Okay, same answers, 5/3, -2, 7/2, and 3, just a different method, different way of getting there. And so then it asks, well, which one do you prefer and why? Okay, I think factoring is easier or faster, really. It's not easier, it's just faster because there's nothing hard about the quadratic formula. It's just simplifying, but there's more places you could make a mistake. You know, you can mess up a multiplication or something silly, and it would mess up your answer. And it's harder to do that with something like factoring. Okay, but totally up to you which method you prefer. But you do want to be efficient. What's the fastest way that you can solve these quadratics? One thing I wanted to mention is that these quadratics don't have GCFs, but if you do have a GCF, whether you're factoring or doing the quadratic formula, you can take out the GCF first and then use the smaller a, b, and c value that you're left with inside the parentheses, just to make the numbers a little easier when we're doing the quadratic formula. And I'm sure we'll run into one at one point, but just wanted to mention it while it kind of popped into my mind while I was factoring here. Okay, so that's our quadratic formula. For right now, we're going to just look at ones that are factorable, but I do want to talk about what it looks like when there's just one solution. So first we have this, and so we'll remind ourselves, what does it look like when we're factoring? And then what does that look like when we're doing the quadratic formula? So here we have another quadratic. If I were to factor to solve, so first of all, I have to get it set equal to 0. And then factoring this quadratic, positive c value, negative middle term, and I'm going to have 5 and 5. So when I'm factoring to solve and it's a single solution, that's when I have that same parenthesis twice, or I have 2x minus 5 squared. So I only have one solution, x equals 5/2. I have one solution twice. And we talked about that that means on my graph, so 5/2 is 2.5, at that point, that the quadratic would just hit at one point on the x-axis. It would look like that on my graph. Okay, so if I have just one solution, again, I've counted twice, that's what it looks like when we're factoring. Now let's look at it using the quadratic formula. So again, to use the quadratic formula, just like factoring, we have to get it set equal to 0. A equals 4, B equals -20, and C equals 25 here. So x equals negative b, -20, making it positive 20, plus or minus the square root of b squared, 20 squared is 400, minus 4ac, all over 2a, and 2 times 4 is going to give me 8. And what happens here is I get 400, and then 4 times 25 is 100, times 4 is 400, and it's going to be subtraction, so I only have one negative there. So I get 400 minus 400 underneath my square root, or I get the square root of 0, which really just means I have 0 here. I'm not going to add or subtract anything. So when I have a single solution, instead of splitting it at the end and doing 20 plus a number, 20 minus a number, my solution is just 28s here, which we're going to reduce going to divide these both by 4, giving me that 5 halves, which is the same solution I have over here. Okay, so that's what it looks like if we're doing the quadratic formula, and we only have a single solution in the end. Okay, so now I want to give you a try on this. So I want you to not factor this right away. I want you to first get it set equal to 0 and use the quadratic formula, and then go ahead and solve it by factoring as well. So pause the video and do that, and then restart the video to wrap up notes. Okay, so first method of solving using the quadratic formula. Again, what happens is that I end up getting 36 subtract 36 or 0 underneath my radical, which means my solution is just going to be that -6/18. That reduces to -1/3. Factoring this, it's perfect square trinomial, so I get the same parenthesis twice, giving me just one solution of -1/3. Okay, same solution, just a different method of getting there.